Hello and welcome to Math 253, Calculus 3 here at Cañada College. My name is Lapuz. In this video, we'll take a look at checkpoint 6.51. They want us to find the surface area of the surface with a given parameterization. So we do have the limits here for us already. That's great. We have limits, and we just have to remember that the surface area function or formula will be a double integral, or it's actually the surface integral, integrating over this particular surface of 1 ds, where s is going to be the magnitude of the parameterization Ru cross Rv, the cross product, and then your s becomes dA, where a would be du dv or dv du, depending on the order that we want. So because these are both constants, or these are all constants, all the limits are constants, then we have the freedom to choose whatever we want. So we'll decide that later. But for now, we need to find Ru, the derivative of this parameterization with respect to u. So we get 1, we get 2u, and there's 0 here because there's no u's in there. With respect to v, we have 1, this is 0, and this is just 2, the last component. So if we do the cross product, Ru cross Rv, this will be a vector. So in the x component, I'll have 2u minus 0, or 2u times 2 minus 0, that's 4u. In the y component, I'll start off with a negative sign. This is going to be 1 times 2 minus 0. So that's just 2. And then in the third component, we have 0 minus 2u. All right. We will want the magnitude of this, Ru cross Rv. And so this will be the square root of 4u squared plus 2 squared plus 2u squared. They're all being squared, so I'll just make them all positive. And I have a 16 plus 4 is 20. U squared plus 4 here. Suppose we can factor out a 4 or a 2 from the square root if we wanted to. I don't know if that'll make things easier, but we'll just leave it like that. So that's basically it. So now we have our surface area according to the formula. It's this thing, but this thing translates to a double integral. And we start off with this 20u squared plus 4 under a square root. And then we can decide, let's do du first. U goes from 0 to 3, and v goes from 0 to 2. Now this probably will involve something to do with a trig substitution, but let's get past all that and just integrate using an integrator online. I'm using Wolfram Alpha, and now we're going to integrate from 0 to 2 on the outside, 0 to 3 on the inside. Our integrand is going to be the square root of 20 times u squared plus 4, and then we'll integrate with respect to u and then with respect to v. All right, so we'll figure out what that is, or Mathematica will figure out what that is, and we get this quantity 43.02-ish as a result. All right, I hope that helps. Good luck.